Hi everyone. Welcome to DoK Students Day. I hope you are having a really good time here learning about so many topics of Kubernetes. And so, yeah, let's get started. My name is Polok Ghosh, and I am a DoK community member, and I am a DevOps and ML enthusiast, and I specialize in Python. Before we go on with this talk, I would like to, take screenshots from this learning and share it in social medias that what you have learned. And yeah, let's get started. For example, when a lot of developers work on the same cluster and they fall into some lot of data, right? So what if they update it and they do not find the value that they had updated, and they have to recreate another cluster, another nodes, and as the same thing happens again, and you don't know where to store it properly, and the developers go like, no, I cannot do it. So for that, HCD is a really important thing for Kubernetes now. By definition, HCD is a strongly consistent distributed key value store that provides a reliable way to store data that needs to be accessed by distributed system or cluster of machines, for example, Kubernetes. So it manages the configurational data, state data, and metadata for Kubernetes. It handles leader election during the network failures and can also tolerate the machine failure, which we will talk in the later section. So before that, let's talk about what were the problems that we had to face when HCD was not there. So scheduling the pods to run on worker nodes. The worker nodes, you have to work specially on that to make them run. And imagine there are a lot of them, right? So then running a pod on a worker node, then handling the API request from kubectl for each of the worker nodes, and obviously monitoring and networking. That's the biggest thing. Like if you cannot maintain, then what is the use of it? So like how things were done before. Traditional SQL was used, like the very basic, and not so distributed to run multiple nodes, because now everything is so distributed, you need to run multiple nodes, and using arbitrary data relationships. So that's it. What were the challenges? What was the challenges communities, people had to face? Inconsistency. Inconsistency is that where you work on several clusters, and then they're not functioning properly. They're failing to give you the desired results. So that brings in the inconsistency. Also, corresponding to unavailability, that the request that you put through client is not giving you back the result you wanted. And obviously the speed issues, like you need to have since you have a lot of clusters, you need to have a really good speed, right? So that is the issue that we had. And then reliability, obviously if it fails, then you cannot have any reliability thing right there, right? So that's it. The HCD thing, when did it come? How did it help? So since its adoption as a part of Kubernetes in 2014, HCD's usage and community had exponentially had grown. And the companies like CoreOS, Google, Red Hat, IBM were many more and part of its contributing members. So what change did it bring in the community? It was the introduction of the raft-based algorithm in HCD. That means when you put a request through a client on the worker node, it will update each and every node that is connected with it, and especially the leader node, so that whenever you send a request through a client, it gives back the result that you wanted. And that said, it makes it distributed throughout the system properly. So that helped in choosing a leader for a given term when cluster holds an election. So correspondingly, then it helps in consistency and high availability whenever you wanted the data to come up and at the latest write access on all the hosts in the distributed system. So how this worked? So by example, I'll show you like how did it work with and without HCD. So these are the nodes connected to a master node, where, if, for example, all nodes have a value of 15, right? So where since you work on this 15 and you update one of the worker nodes, right? So if without HCD, the request, when you put it back again, and you don't know which node was it. So you don't know, suppose you updated to 17 and you do not get the 17 back because you don't know where it was. But with ETCD, what will happen is, suppose you put a client, a request for a client on this worker node of value of 17, all of the nodes all of the nodes will be updated to 17 and will be distributed properly when you request for it. This only happens when you have ETCD. So if you want to explore more, there is a video and a blog regarding ETCD, and it will be a more elaborate way of explaining here. And so if you want to learn more, you can go through, check these websites out. So we'll go through a summary where we went through what is ETCD, starting from the past, changes when ETCD was introduced, how ETCD worked, and resources. So I want to give big shout outs to Bart Farrell, the Bain man. He really helped me into knowing which topic was really good for me to work on. And Vanshika really helped me with the slides and the presentation, and which made me, made my work really flawless. So that's it. Thank you so much for this. Thank you so much for staying with me in this talk. And if you have any questions, if you want any inspiration regarding Kubernetes or this talk, you can check out my social handles, and I'll see you again the next time. Bye-bye.
Okay, excellent talk. Very, very clear, well organized, amazing slides. No secret there that graphically speaking, that was very, very clear. Much appreciated.